All right, so this is what we're gonna, what we have announcements. Remember, exercise 3, the sum of 3 numbers is due tonight, so finish that up. Exercises 4 through 10 have been posted, as I just said before I started the recording. These will really help you solidify the common concepts from the week, things such as input, string operations, branching, and we're going to talk some about looping today. They will also help you on project 1, which is due next Friday. The exercises are due next Wednesday. Again, keep me informed about how you guys are feeling with things. Like, I was thinking about just posting exercises we encounter them in class, but I don't know about you all. I think as math people, we are people of patterns, and it didn't feel like it was enough of a pattern. So I might be looking at like a Friday to Wednesday cycle for exercises. And then like the projects are on a 2-week rotation with Fridays. So that's kind of what I'm looking at, but do keep me informed on how you guys are feeling, and if something's just like, hey, Mr. Tesler, this is not working for us, please do come talk to me so we could adjust and make improvements. Quick follow-up about the input function. Input function does not need an argument, so let's just go ahead and illustrate this, and I think you've probably noticed this when it came to your homework. If you were to go ahead and just not put a prompt inside the input, it would be fine. So let me change that. So if I were to just do like x is equal to int, and then we'll say input, and not put anything in there, it's just going to look weird because when it goes to actually, I'll say you inputted x. So when you actually go ahead and run this, it's kind of a little bit confusing because it just looks like your computer is like took a nap and it's like you're expecting to do something. So of course, you don't need input for that. So you inputted 4. The other thing I could go ahead and say that you'll encounter, print does not also need an input. Print, you can just go ahead and leave blank and say you inputted 4, yay. So now if you run this, I'll say 7, you can see that it defaults to a new line. So one other thing that you might start seeing if you don't like this setup, but you are like going through steps and you're using print statements to debug and things to that effect, you could always go ahead and force a new line by using /n. Does everyone see the syntax there? By the way, do you guys want these front lights off? Would that help? Alejandro, can you get those for me? Does everyone see how this is kind of colored a little bit differently? So this /n is a special character. The two of them together are the new line character. So now if I run this, you'll see that it does the same thing as before. So it adds that extra new line. So that's something that you're going to maybe run into as you go farther. If you literally want this this character right here, you could go ahead and just do //, and that / is known as the escape character, and it escapes it from doing something special. So we'll probably talk more about strings leading up to project 2 or 3. I have some ideas about those projects that I think will be entertaining projects that will really be beneficial, so we may talk about that more. But anyway, that was just a little bit of rambling about calling functions and not giving them input. By the way, as I walk around and see a couple things that you guys are doing, that just the way you guys are taking notes and things, if you guys highlight like a bunch of lines, and let me see, and if you hit Command /, it will automatically comment those lines out. I've noticed many of you are just kind of like taking notes in the same file, so that's a short little trick. So if you highlight the lines and hit Command or Control on Windows and /, which is the button under the question mark, it'll comment out all those lines. So little FYI. Does anyone have any questions so far? All right, so let's go ahead and talk about, we talked about this a little bit last time, but let's just go ahead and just write a quick program to review what we did last time with conditionals and booleans. So let's say we have x equal to 5, y equal to 6. I'm going to just hard code those. So if x is less than y, we'll go ahead and just print this statement that x is less than y. We could go ahead and consider the other scenario where else if x is greater than y, we'll go ahead and print appropriately that x is greater than y. And then we'll go ahead and consider the last scenario, which we're not going to put a condition with. It's just the scenario that will happen should none of the previous cases result to true. So else, what would be an appropriate print statement for this last case? That they're equal. So x is equal to y. And again, remember that the double equal sign in pretty much every programming language. I think there's like some one esoteric language where a triple equal sign is equal and is and like a double equal sign is a reference equality. But anyway, that is the third case. Remember, a double equal sign is for comparison. And one other thing that I want to make sure is clear, I'm going to put one other print statement at the bottom, but notice that I'm going to remove the indent, and I'll just go ahead and say I am done comparing. So if we run this right here, you can see that x is less than y was run, but the other two blocks were ignored. So that's something, let me see if I can write on my screen just to make it clear. So of these, I don't know if this will work. I'm experimenting here, but so this right here, of those, only one of those will run, but since this is in a different block, it will also run. So kind of Python interprets code as blocks at a time. So this is all kind of one block, and that's in a separate block. So it's selecting one of those three statements to run. All right, so with that being said, I do want to kind of mention there is a lot of flexibility when it comes to conditionals. So let's go ahead and let's suppose we cared, let's just leave x and y as 5 and 6. But if x is equal to y, so let's say we care mostly that they are equal to each other, we'll go ahead and say print x is equal to y. And else, we can go ahead and make, and again, this kind of is emphasized in the block right here. So the else right there is going to be the other two scenarios that we had before. If x is less than y, we'll go ahead and print that x is less than y, and else print that x is greater than y. So again, just the blocks right here, we have a couple more. So we have this block right here, but within the else, we have this other block right here. So again, indentation is very important within Python as it defines blocks of code. If you were using like C, you'd be using curly braces to indicate blocks of code. So just wanted to kind of make you aware that you are able to nest conditionals within other conditionals. So there is a general rule though that you don't want to nest over nests, and we'll talk about styling a little bit more when we get to project 2. So that's a little bit of review from last time. Any questions on these? All right, so let's go ahead and consider one more scenario with conditionals. If x is, let's do this way. How do I want this? If x is greater than 0 and x is less than 10, let's go ahead and print that x is a small positive number. Else, print x is something else. Because I want to go ahead and just make you aware of this idea of using a Boolean operators, namely and. So each of 0 or x is greater than 0 and x is less than 10 are going to evaluate to either true or false. And of course, if both of these evaluate to true, then you'll go ahead and see this run. And we can run this and you can see x is a small positive number. But if you were to go ahead and say that x was 10, or let's say 11, so it makes it clear, you can see x is something else. So even though that this is true, this is false, so that's why the and evaluates to false. Maybe a little bit of review of discrete. Python does have a nice kind of syntactic flair that you can use compound inequalities within Python. So you actually could go ahead and just do this as 0 is less than x, but this is a Python thing. So if you're in another language, you might not have this same convenience. So you can see right here. So Python does support compound inequalities, so you could kind of shorten it to that. All right, so let me go ahead and hide my screen. Hide my screen one sec. I'm going to do this, and let's go ahead. All right, so I'm going to go ahead and redo that guessing game. So remember, we're going to just redo the guessing game. So let me ask you all for input, and the so let's get this in our standard way. Let's go ahead and we're going to grab input from the user, and let's just say I am thinking of a number. Try to guess it. All right, and let's think about what logic we would have to go ahead and do. I went ahead and I hit it on line 1 because I want to see how y'all do. So if target is equal to guess, and I have hidden target, that is what you guys are aiming to answer, I'm going to go ahead and say print, that's it. That's it. But the other scenario is, well, print, you lose. All right, so I'm going to run this. Okay, I am thinking of a number. Try to guess it. What do you all say? 50. Guess what? You lose. Game over. How lame is that? Don't you feel like you should be able to get more than one guess? It would be really nice if I just, okay, Kenneth, you want to give it a try?
I do.
What is it? What's the number?
4,312.
4,312. You lose as well. But anyway, it would be nice if you were able to continue guessing. So that's what we're going to go ahead and introduce with the while statement. So again, by the way, does someone want to guess 55? Good guess, Caroline. Oh, good job. That's right. That's it. You got it. So it's one of those things. It's a pretty boring game as of right now, but we have a lot of things that we can go ahead and do to start improving it. So what we're going to do is introduce the while statement, and you can see up here I went ahead and pre-programmed the target. So let's go. How would we do that? Well, let's go ahead and introduce the while statement. So notice in blue, so that means it's a keyword. So it's something that you can't define the statement to be while. And what you're going to do next to while is put some conditional. So while, and again, I don't know what, we'll figure this out in a sec. what we're going to do is just continually, bless you, we're going to continuously prompt the user. So guess is equal to int input. I am thinking, or I'll say, nope, try again. So, and then if while ... What is the conditional though? So what do we want the guess to? What is the conditional we want to basically win the game? We want the target and the guess to be what? The same. So how would we code that? Well, we would have to say the target is equal to the guess. Is this correct? No, Alejandro, what's wrong?
It shouldn't be equal.
It shouldn't be this equal, it should be double equal. A single equal is the assignment, and then the double equal is the comparator. So while the target is equal to the guess, but what do we don't want, we want it to be equal. So we don't want equal, we want not equal. So while the target is not equal to the guess, we're going to continue asking them. Yeah, and that's what you were going for. All right. But once they got it, it's going to basically stop re-executing what's in that indentation block, and, well, you win. So let's go ahead and play this. You can maybe try it yourself. Let's say 60. Nope. Again, let's try 46. Let's try 51. 55. You win. So maybe just to visualize what a while loop does, let me go ahead. I think I had a picture here over here. But this is essentially what a while loop looks like. You're going to hit a statement, a comparator, and as long as it is true, you're going to continue going to execute some code and then coming back to it. But the moment it is false, you'll go ahead and exit right here. So that's exactly what happened right here. This continued to be false, but the moment it was true, we skipped this and went through another path through our program. So that is the while loop. Does anyone have any questions about the while loop? Go on.
Can you nest, like have multiple conditions?
Can you have multiple conditions? Like, what do you mean? Like could you put another while in here? Is that what you're asking? Like
let's say we wanted to say, let's say they type in like 42 with words. Could we make it say put it as a number?
Sure. So you're basically saying, hold on, let me think about this. So you're asking, can we check more conditions here? So like while guess is not equal to 2 and guess is greater than, is less than 1 or something like that?
Sure, or could we make it so that we give them a different error? Like let's say they guess a negative number and we say, no.
Yeah, so what we would probably do there, instead of trying to put the conditions as there, is we would go ahead and maybe add checks in here and say, so we grab it and say, if the guess is less than 0, and just maybe tell the user like it won't be negative or something like that. But I think what you're starting to get into is like, what if we had more, and this is kind of a hint for the project too, like, so you're checking like some condition once you're in the while loop, but there's more to do. So you could go ahead and you could basically exit the loop early, or you could continue on to the next one early, or the next iteration early, and we'll talk about that a little bit later today. So yeah, let me go a little farther with while loops, and then we'll see if that answers your question. Because right now I feel like I'm explaining it abstractly, but it's nice to have some concrete. Okay, so couple things to be careful of when it comes to the while loop. Let me go ahead and I'm going to just save this code for later in case we need to come back to it. So new file, we'll call it guest.py. I'm going to just save that for later and we'll do that. All right. So one thing that we should be careful with while loops is let's say we're just thinking about n. While n is less than 5, let's go ahead and do something. Let's just go ahead and print what it is. So let's go ahead and print f n is less than 5. So let's run this and see what happens. Okay, it threw up an error. That's fine. N is not defined. If n is not defined, what does that mean? Does anyone know? I need to assign some value to it first. So let's go ahead and put n outside the while loop. So before you get to your while loop, you need to go ahead and assign the variables that you're comparing. So let's say n is equal to 0. And now let's go ahead and run it. Uh-oh. I'm stuck. I am stuck in a while loop, and this will go on for a while. So as you are programming your projects, if you get stuck, right here we have the advantage of hitting this stop button up here, but let's say you're in another file. What you'll do is hit on your computer command or control. Hold on, I am truly stuck. There it is. It's Control C. Control C is a convention that if you're on any machine, it is going to cause your keyboard to interrupt what is happening. So it stopped the program. So again, that was Control. So on mine, it was CTRL, Control plus C. So make sure you know how to get out. So go ahead and get yourself stuck and get yourself unstuck. Any questions on that? Does anyone have any issues with that? So that's a little tip in case you find yourself stuck in a while loop. So while you're constructing while loops, pun intended, you should always have some sort of logic that affects the variable you're conditioning on. What do you guys want to put? Let's change n. How do you want to change n? Do you want to add to it 2, 1? I don't know. I was giving you guys the option. You're all just staring at me. 2? You want to add 1, 2? Caroline nodded with 2. So again, you could do this. Remember, you can also go ahead and say plus equals 2. So now if you run this, we do have a scenario where we will eventually evaluate to a false and then continue and say, then if you just to see it, I am done incrementing, just so you can see it. So that's a while loop. This n is sometimes referred to as a counter or a counting variable. So let's go ahead and do one kind of exercise together, and then I'm going to give you something similar. Because it'll illustrate something known as a break statement. So I'm going to go ahead and just erase this. Does anyone have any questions on this before I delete it? All right. So let's go ahead and consider a little exercise. Find a positive integer that is divisible by both 11 and 12. So this is a little bit of a number theory question. While loops are great when you don't know how long or how high you're going to have to go. So like you don't know, for our guessing game, we don't know how long we're going to have to guess. For this right here, I don't know how many times I'm going to have to check if a number is divisible by both 11 and 12. So what we're going to go ahead and do is, there's a couple ways to do this. I'm going to just go ahead and say x is equal to 1. So I've declared the variable I want to go ahead and consider. But it's like, for example, maybe you don't care necessarily about the numbers. So I mean, you could just go ahead and just say, well, there's a couple ways to do this about this. So what are we looking for? We're looking for a certain number that holds these conditions. We don't know what it is. So like, do we stop at 100? Do we stop at 1,000? Do we stop at 10 billion? Or do we just want to stop when we found it? We want to stop when we found it. So I am going to basically write a loop that will keep going. I am going to intentionally get myself stuck in this loop because I want to go until I find it. So while true is going to basically put you in an infinite loop. But there is a way to get out of it, and there's a statement called a break statement. So you'll break out of the loop. So how do we do this? While true, I'm going to go ahead and just tell the user what I'm checking. I am checking x. But how do I check if a number is divisible by another one? Does anyone remember what operator we would have to use? You would use the mod operator, not the division one, or unless if you were doing that and then the two. It's a percent symbol. Percent symbol. Yeah, it's obvious when you have that context, but yeah, we're going to need to use the mod. So what we're going to do is if x is divisible, so it has a remainder of 0. So again, remember this is saying what is the remainder when x is divided by 11? If it is 0, then it has no remainder, so it's divisible. And x is divisible by 12, so that is just using this modulo right here. So if this is the case, what we'll go ahead and do is break. And then I'm going to go ahead and print x is, well, I need to say what x is, so I'll go ahead and say x is divisible by both 11 and 12. So I'm going to go ahead and run this and see what happens. I am checking 1. By the way, I intentionally leave these bugs because you're going to probably do these as you think about learning problems. What is wrong with what I've written, or what am I missing? I'm never incrementing. So again, I'm going to go ahead and stop my program. So Control C, I keyboard interrupt, and then we'll go ahead and have to go ahead and increment x by 1. So now if we do this, 300 or 132 is both divisible by 11 and 12. So something I just kind of want to put in the back of your mind for a moment. This type of algorithm is using something known as exhaustive enumeration. Guess what? It's slow. Some may even say it's exhausting. Okay, that was bad. But if you think about what we're doing here, this is not a very efficient way to do it, checking one number at a time. So what we could say is this algorithm has an asymptotic complexity that is linear. So that's something we're going to talk a little bit more right around spring break, is how effective is a certain algorithm at solving a problem. This one will basically scale in linear, but if you think about just some food for thought, what is a function that grows slower than a line? Anyone know anything? What's the function that grows slower than a line? So a line just goes up. A constant is great because you know what a constant means is it's not growing at all. So I could throw at 100 or 1 billion and it's going to take the same amount of time. So that is the goal of algorithms, but another good one is like a logarithmic function. So a lot of our functions will describe how our algorithms are running, and our goal is to basically get algorithms that do not grow very quickly. So the logarithms are pretty common. Constants are like godsends, but that's a little bit more later in the course. So let me go ahead and give you an exercise. This one might be a little bit trickier. Let's see, I think I already have it up here. So the exercise, just to kind of give you something to do, would be this one. I'm going to hide the solution. Find the third positive integer divisible by both 11 and 12 using exhaustive enumeration. So let me give you a few minutes there just to kind of play with that problem. And we'll talk about it and go from there. Hint 1. You might want to declare another variable to keep track of how many you have encountered. Make sure you declare it outside or before the while loop. I guess you don't have to, actually. That's interesting. Oh, no, you don't have to. So, never mind. Nix that last sentence. You could declare it either before or after. My initial algorithm did it before, but you could declare it. Well, no, you will need to declare it after. And that's an interesting. We'll talk about that. Let me give you maybe about another minute and a half, 2 minutes on it, and we'll go ahead and solve it together. All right, let's go ahead and see how we could do this. Anyone think they got a solution? Anyone get it? So I gave you a hint with another idea. And we got to be very careful with where we declare variables. So let's suppose, okay, we need the third one. So I want to go ahead and I'm going to declare another variable called encountered and set it equal to 0. I'm going to first declare it here because I'm going to need it right here. But if I don't want to break after my first one, what I want to go ahead, I'm going to call this encountered, so just grammatically a little bit more indicative of what we're doing. But if it is true, I'm going to go ahead and increase, or if we find one that is divisible, I'm going to go ahead and increase the encountered by 1. So, and then if encountered is equal to, what did I say, the third? That is when I want to go ahead and break. So I'll say x is the third integer that is divisible by 11 and 12. So let's think about this for a sec. Just kind of step through it in your head and think about, is this going to work? Let's go ahead and run it. So if I run it, I'm looking at this, and it's something in you saying like, hey, this doesn't feel right. Like I feel like I should have encountered the number well before 40,000, right? So here's a tip that you can use as you work on larger projects. So let's go ahead and instead of like doing print statements, we could try and like print and like what is encountered. Does everyone see over here on the left this little play with a stop button? So that is a debugger. So we have this built into Replit.com. Again, you could find these in pretty much every language. And you see where it says breakpoint? Breakpoint is where you're going to basically stop your execution, and you're then able to go through the algorithm one step at a time. So I want to go ahead and stop it just inside the while loop. So I'm going to just click to the side, and everyone see that blue dot? Yes? So I click here, it makes a blue dot. Is everyone good with that? I just click on the column to the left, kind of left of the numbers. And then I'm going to hit this run button. So you can see that, well, there's a lot here. Let me do it one more, clear the console, and then. So you can see right here, this line is blued, and basically the program is paused its execution, and you can now look at a lot of things. We'll talk about call stacks later this semester. But you can see X is 1, and what you can now do is step through your code one step at a time. So I click encountered, or you can see it's about to run encountered. The one that's on is the one that's about to run. So you can now see encountered occurs over here at 0. And if you were to kind of, you see this didn't evaluate, so you go through this. But as you go through this line by line, you might realize something. Yeah, Kenneth, question?
Mine isn't showing any of that, and I think it might be because I'm not in main.
Yeah, it is a restriction to main. So if you would just have to copy and paste your code over to main.
Okay.
So, and again, I left this as a tip session in the project. It might be good to go ahead and kind of write your program in main and then copy it over to the file to submit through for the program. Yeah, Carolyn. I wonder if that's related to your other issues. I'll look at it more afterwards. So that's just something I wanted to make you aware of. That's a debugger. And as we've gone through this, is anyone kind of can maybe describe the bug that we have in the code right here? Alejandro?
The second if statement is inside the first if statement, so it's never.
That's actually okay. This will actually run as long as we fix another bug. But again, this one will run as soon as encountered is equal to 3. And realize you really this is actually a good placing for it. Because the only time you want to check if it's the third one is if you already incremented it. If you look at this, what are we doing right here? Every time through the loop, we're reassigning 0. So we will never get encountered to 3 because every time through the loop, we reassign it back to 0. So what we need to do is actually put it outside the loop. So I need to stop this. And if I put it actually encountered equal to 0 outside of the loop and run it, you can see that 396 is the third integer. And this one's a little bit of a large number, but I would encourage you to maybe try with like 2 and 3 and then debug so you can see that 18 is the third integer divisible by 2 and 3. Right? No. What's the third integer divisible by both 2 and 3? So is it, 6? So 6, 12, 18. Sorry, Friday. All right, so that's a fun little exercise. Any questions on this one? Okay, in that case, let's go ahead and talk about another type of loop. So any other follow-up questions here? All right. So the other type of loop I want to talk to you about is the for loop. So again, just to kind of have it for reference, don't need to type this. We said x is equal to 0. Then we said while x is less than 5, we said we printed x, and then we went ahead and incremented x by 1. So it's the same thing we did earlier. There's another way to go ahead and do this same iteration. It's a little bit annoying to have to declare this first and then remember to do this. So this incrementation. So it would be really nice if we could really have some sort of other structure that allowed us to work with that a little more easily. And we do. So I'm going to just comment this out. And that is saying 4x in range of 5. So this right here will do the exact same thing as above, print x, except for it removes the need to previous declare the variable. It basically declares it right here, and it takes on the values 0 up to 5 non-inclusive. So you can see, so this is just the same thing as above, except for x is basically declared here, and it will take on the values 0, then 1, then 2, then 3, then 4, not 5, because it is a less than strict. So this might be useful as you think about this weekend and you're working on your projects. What if you really, do we have any golfers in here besides me? So in golf, if you hit your golf ball towards someone, you yell 4, spelled F-O-R-E. But let's say you really don't want to say that word otherwise, or say that number otherwise. So you can say if x is equal to 4, don't do anything else. Just go on to the next iteration. This will be great if you're like guarding against a certain type of input. Just a hint. So you can see now when I run this 0, 1, 2, 3, 4, nothing after this was executed. So just to illustrate that, go away. There we go. So to illustrate, this is all one block. But if we hit this continue, we skip everything else that is after it and just go back up to the top, iterate x by 1. So we can also do a bunch of other things in here. So like you could also like you could have done like, you can like add to x. I wouldn't recommend that you do, here's a caveat, don't change x in this loop, because x will automatically be updated here. So like, let's suppose we had an exercise. Let me give you 2 minutes to try this exercise with this. Let's say we have to compute the sum of the first 12,345,678 squares. How would you do that? You don't necessarily need a while loop here because you know how high you have to go. By the way, in terms of the mathematics, I'm asking you, here you go, Calc 2, to compute I equal to 0 to 678, I guess, 9's not there because, 789, I get it, okay, of I squared. So this is the problem we're trying to compute here. Let me give you a minute or two to think about that. With the 40, you need to go ahead and add up the sum of a lot of squares. Just an example of something like this. And maybe just to help, I use I here, but technically matching this, we want to compute the sum of the first 12,345,678 squares.
Raise a number, it's a
double asterisk. So here is a solution to this little exercise. The total, remember I said you don't want to change x because that's what you're iterating through. So what I'm going to do is kind of show this summation sigma, the capital sigma, as a total. The reason I don't want to use the word sum, you might think, oh, it's the sum, let's do it, is because sum is a function, so I don't want to overwrite Python's implementation of sum, S-U-M. So that's why I called it total. And then I could print this, and I could run it, and thank God, who was it for Gauss? Was it Gauss who did the formulas? Because if you think about it, I was able to talk for about a good 10 seconds before that answer came up. Because if you think about this, kind of based off of earlier, this took a linear running time, as in as the problem grows bigger, it takes longer, where that formula that you guys have in from Calc 2 is a constant. You just plug in the numbers, you're done. So did anyone get this? That's okay. Again, just illustrating a question.
I'm getting an error.
You're getting an error. Okay. Let me take one.
It says total is defined.
Make sure you have to declare it before you get into the loop. So.
Mine says cannot assign to the operator.
So did you use sum?
No, I said.
I'd like to see the bug.
Is it because my credit is ending?
So you don't ever want to do any sort of computation here. For x in range, what I'm going to go ahead and do is notice again what you're trying to do, x equal to f. If you were trying to do this right here, that double parentheses there means square. So what you'll go ahead and do at this point, let me write it like this. Total is going to be what it previously was plus the sum of the new terms. That may make it a little bit more obvious. And then then we can maybe just step through this to see what is happening. So let's go ahead to our debugger. And if I kind of run through this, you can see our first time through, our total is 0. And our x is equal to 0. And then I'm going to go ahead and step. And it's going to go back to the top of the loop. It's going to update x. So x is now 1. And I'm going to go ahead and add to my total what it's currently valued at, and plus the square of what our x is. Then I'll go ahead and do my next step. And you can see right here, as we step through, total is now 5. I'm going to square 3. Add that. It's going to then be 14. So I would encourage you, especially as we get to the loops, to maybe play with that debugger a little bit more to understand what is happening. Any questions on that one? Any other questions? By the way, something as you get larger numbers, don't you wish you had commas? Can't use commas, but it would be nice if we could use commas. You can use underscores, and it will ignore those underscores. So that's a quick little way to still work with separators. So if you want to go ahead and do that, that's helpful. Any questions on that one? Here's a little tip for your project, and then we'll wrap up. I realize the time. Just want to show you this. If we looked at 1.23, is that a float? If I were to go ahead and let's go ahead and wrap this in here. Let me do it like this. X is equal to 1.23. X is a float, but if you go ahead and do .is integer, so go ahead and just show you this syntax. We'll talk about it more next class, but just in case you make some progress on your project this weekend. Do you see how I do this x.is integer? This will tell you whether it is an integer or not. But if I were to do y is equal to 1.00, yes, that is a float data type, but numerically, is 1.0 still an integer? So if I do y.is integer, it's going to say true. So this is a way to check if something is an integer. So that'll maybe help you a little bit with some of the bugs when it comes to part 1 of the project. You probably won't encounter that bug in part 2 of the project. So if part 1's giving you some trouble, I still want to talk about floating point. We'll have to do that on Monday though. But does anyone have any questions from anything we talked about today? All right. If you do, it is my office hours, so feel free to stick around. Otherwise, enjoy your weekend, and I will see you all next week.